Hello everyone. So this video is going to explain how to do the lab exercise. Click on the lab exercise here, which say what's here. The first exercise to install Java. So that's essential. You must have the Java virtual machine and Java JDK installed on your computer to do that. We need you to install JDK 221, right? So this is the latest long service version, right? Okay, so depending on your computer, Windows One or Mac computer, you should always go to this website to find the correct version to install. So verify if you have installed Java or not. You can come to here. We use the VS Code as the editor, but later on we're going to use the IntelliJ, right? Just type in Java version. Okay, say Java version 21, right? That's installed. This is a long support version LTS. Okay. All right. So that's the first one is ready, and the second one is try to do the practice with JS shell. Right. The JS shell probably is better just to use the you use the terminal to do this exercise. Right. Here we have a terminal. Okay. We can use the JS shell. Right. Type in JS shell. We come to this environment. And then we can try to do the exercise like here. So we can type in something like 10, right? And b equals 20, something like that. And we can system.print RNA, right? So this is Java way to output something, right? Print here. Right, print out 10, right? So you can do this exercise. So it's quite easy. And the second one is Boolean, right? So the Boolean, we can try the Boolean. Like Boolean is equals A equals B or not, right? Right, so that we can see the value is false because A is 10, B is 20. It's not true, right? And also you can try this exercise by yourself. Later we can try the typecasting. Double x equals 0.7, and then we have y equals x. Okay, so in this way, because y is integer, x is double. So this casting is, you cannot use implicit casting. The reason is this one is going to lose some information. So it's going to show the error, right? And if you print system.out.print y, we don't have that yet, right? So it's not successfully assigned the value. Now we need to say y equals x, so explicitly casting narrowing, right? Here, okay, then y is 9. Remember, for the casting, it's not round up, right? So even 9.7, when it casts to integer, they only keep the integer section, so that's cut off. So it's not round up. Okay, and now we can print up. Okay, it's 9. All right, so that is JS shell. JS shell is just a very easy way for you to try some Java statement or Java functions. But when we build real project, we cannot use JS shell. Just try to play around with some Java statement. Okay. Okay. Now we exit. Okay, so this one is finished. The third question is the most important. Third exercise, most important one for this week's exercise, to use Git and GitHub, right? Okay, you need to, if your computer doesn't have Git yet, you need to install Git. Come to this website to install Git, right? Otherwise, you can check if Git has been installed. We can Git. Okay, so it's Git version. So that means Git has been successfully installed in my computer. Now we're going to create an empty folder, right? To use Git is create a project. A project should have within a root folder. So one common problem I made fund student is sometimes they create a project and then create another project under that project. So that's not true. When you create a project, you should only create a project by itself, not inside another project. You look here, I have a folder called OSD, so that's our course project. So this is a folder, but this folder doesn't contain any project, right? It doesn't contain any file yet. It's totally empty. Now we create a project. Uh, project one, right? We create a first project. So this is a project. So if we use Git, Git should within this project, not within this one, right? So look at this. We cd get into here. So project one. So this is the root directory for my project one project. So I can have multiple projects. So each one probably project one, project two, and so on. Not one under that. So this OSD projects. So this folder is not one project, right? So this just empty folder. This folder hold other project, right? You shouldn't use Git in this project directly, right? So otherwise you will cause one project within another project, something like that. Okay, now we have a project. For this project, I can create a file readme.md, right? So it's common here. So this is the first project, right? Okay, so the MD is Markdown language. So this is very commonly used for software project, right? Okay, and for this project, I probably create a folder. SRC, right? Create a folder, and the source code probably under the source project, like dot. We can create dot Java, right? Okay, and so we create Java. Okay, public should be public static void okay, printing hello world, right? Okay, so this is our project. We only have one file here, right? And also for a project managed by Git, it's better to have a git ignore file, right? So that's what we see. This source file is under the source folder. README is under the root folder, right? For the git ignore should also within the root folder. We create one dot. Okay, so this has no extension. So this file explains which file or folders will not be managed by Git, right? So in our case, so because for the project, we only hold the source code dot class, so that is the compiled binary code will not be managed by this directory. Okay, we create this. Okay, we look here, it's main, okay, and if we come into here, we can Java say main.java. Okay. Oh, sorry. This line, Java is very strict language, so therefore for each statement must have a semicolon here, right? Here. Okay. Let's say we compile that, we also create the class, right? That git ignore why it doesn't work. So probably haven't saved that. Right, I have got here. I got git. That's all right. Okay. Now I have the git ignore, but we haven't really started this by git yet. We look as here, so this look as the directory. We have readme source and git ignore, but we haven't initialized git yet. Look at this one. We need to git initialize, right? We initialize git to create a git repository for our project. Do that, type in git. Sorry, what problem? Okay. Okay. Type in git init. Okay, so this is going to initialize the git. Once you have initialized git, in the CVS code you see here we have git, we have 3 files, right? And also you look at this file, this green one is the new file, right? And this is green. So even though it's a new file, but it's not managed by git. The reason is we have exclude dot class file, right? So in our project git. And then the next step is we git add dot, right? Remember, this one means we have create new file or modify file. Whatever we have changed, we need to use git add. So this one is going to add this git into our repository. And after that, we need to git commit. Okay, this puts some command. First commit -m. So remember this command, right? So this is very commonly used. Okay, after that, see this disappear and this file added to the commit. Now we have managed the git. We look at git status, branch, and nothing to commit, right? And git okay, we have main, right? So this is the git creates the project here, and now we need to connect up because Git is for the repository, but it's managed in your local computer. We need to connect this with a remote part. Therefore, it can be shared by different developers, everywhere, right? So we need to send our repository into the GitHub. Therefore, can be used by other people as well. Okay, we come to here. We need to go to GitHub, right? You need to have a GitHub account. If you don't have yet, you need to create one. So this is my GitHub account, right? You need to create your own GitHub account, and in your GitHub dashboard, create a new project, right? Here, first project. Just right, create first project. Is available. If you have you have already have a project called this name, you cannot use this. Right? And for the project, you can be public. So that means everyone be able to see your project and also be able to download your project. Private, that means other people will not be able to see your project unless you have invited the people as your collaborator. So in this course, when you do your assignment, you should set your project as private, and only your team members be able to access the project, and also the assessor be able to access your project, not everyone, right? But for me, for the demonstration purpose, I just public name and create repository, right? So once create repository here is give you the instruction how to set up the initializer this repository of the project. So git anything that we have done yet, add readme, create the file. We have used git add dot, so add all the files. So we have already done this. Commit first commit, right? We have done that already, right? And we need to branch main, right? So actually we don't really need that because our project is already in the main branch, right? What we need to do is we need this one, git remote add orange, right? Orange is the name of the the remote copy. So the project has one copy on this GitHub. It's called orange, right? And here is the URL. So we need to run this command. To run this command here. Okay, we need to run this command. After we have run this command, we need to run the last one to push. Push is to send your local file onto the internet to the orange from main, right? Send to the orange main, right? And -u means we use this as a default upstream. So only the first time you need to use -u. Otherwise, you don't need to. The first time you use this, after that, you only need to use git push. But the first time you need to execute this command. Okay, so now we can see the file has been uploaded to the GitHub. Now we look at GitHub project. You see, the file is here. Git ignore readme and also the source folder. You're able to see this one. Okay, so this is the first part of this exercise. Okay, so once you finish this part, we continue to the next section about the exercise. You create this one, add file, commit, and also create GitHub account. If you don't have create a new repository, we have demonstrated that. Link local. Here, use this command, right? But here your name, your repo git, right? Better to copy directly from GitHub. Push orange. Okay, now we try the second part of the exercise. So look, so we are within the project one. So if we can say the dot. Okay, now we are in this folder, right? So suppose I'm another student, and also I'm joined to this project. I don't need to create a project again, right? Because the project I have already created and on the GitHub. What I just need to clone that from GitHub. So I type in git clone, right? And I need to have the directory of that one. Directory, so this project. Click this code here. They have HVS. Here is the directory of that. Click this to copy and come to here. All right, git clone. So this is a directory. GitHub username, project's name, right? Clone this. Okay, you can see I create another folder called first project. And this project, they have exactly the same stuff, right? Okay, so when you first time create a project, you have a name of the folder, and once you create a link to the GitHub, I use this one, so the name could be different, but the content is the same. Now we close these files because I don't want to be confused, and first project. Now I get into the first project, right? So this time I'm working on this folder. So this is the initial one. This is the second one, clone from the GitHub. Suppose this other student. If only one student, you don't need to really bother for that. So I just suppose I'm another student. Use this one. And now we come to a very important part of today's exercise is to introduce the concept of the branch. Because for a Git project, if you have multiple developers working on the same project, then you need to modify the same set of the source code. Eventually you may conflict. Therefore, the way to avoid that is before you want to do something, you put your stuff in, you create a branch and you're working on that branch, right? So that you're only working on that branch, and when the branch is good enough, you merge back to the main branch, right? Okay, we come to here. Come to this part we look at. So this command is create and switch to a new branch, right? So checkout is switch to a branch. Go -b means create a branch, right? So we can also just use another way, git set new branch, right? Okay, just use, they can use this way to create a branch, right? We can use git set to list. Now we have two branches. One is main, another is new branch, right? So that's this branch. Usually the branch name is create, because each time it should be a unique name. You can use the same name for two different branches, right? So it's better to create your branch with a meaningful name. Like if I want to modify the UI for which class, I will branch new class or which class name or so on. So make the branch reflect the purpose for you to create the branch, right? Okay, now I'm still in the main branch, but I have created this new branch, right? So I can switch to that. Git switch new branch, right? Context. Now I come to the new branch. So now if I doing any work, will not affect the main branch and directly, right? So I'm on this one. So suppose I try to modify is the work new branch, right? Just try to do something. Therefore, we know I have changed, right? Okay, and then we need to see here we have one file has been changed, so we can, of course, you can add new files if you like, but we simplify, just modify this readme, and we use git add dot, right? Remember this is first command means we have something to add, and it commit my first in new branch, right? Right. So for the commit, this message is not unique. You can use the same message multiple times, but better for each commit you write something meaningful. Therefore, when they later read the history, they read this one, they understand what you did for this commit, right? Okay, so this has been added here, and now I need to push, right? So this time, because I'm in a branch, so I also need to push to my branch, right? We look at the command here. Okay, that's it. Add commit push to orange, right? That's a remote site, and also that's remote branch, right? We want to push to there, right? I also can use -u, means we always use that for default. But if we only push once, we don't need to use -u, we just use this one. Push orange, so that's the name of the remote copy, and a new set, right? Better to use the same name, therefore the remote name and the local name use the same, right? Push here. Okay. Create push. All right, so that's new branch. We can use git branch to check. So this git branch is check the local branch, right? If you want to check the remote part, you use -r. The remote part, we can see the remote part, we have main branch and the new branch have two branches, and also we can see the head is to the main, right? So the main is a major branch, right? So the new branch. Okay. All right. Now we come to the GitHub to look at the situation. Come to the GitHub. See the GitHub, they already received this message. A new branch has recently pushed 7 seconds ago, right? We can refresh this. See, now they have two branches, right? And you have new branch has recently pushed 5 seconds ago, right? So now you come to another important part called the compare and the push request. Click here. this is the name of the, sorry, this is the name of first committing here, right? And also this pull request, you can add something to the pull request. Okay, create pull request. Pull request means something we try to merge them together, but actually it's not merged directly, it's just the request. Now we have the push request, right? You come here to look. This is the pull request. Okay, this is the pull request. This create new pull request, but we don't have anything to create yet. So we look at this pull request. For this pull request, you can see the file changes, right? There's only one file changes, right? So the README, this is a new thing here, and there's only one commit there, and also have conversation, because for for pull request, sorry, that means we have done something in another branch. Eventually, we want to merge branch to the major part. But before they merge, they need to make sure they're not going to affect our main branch, because our main branch is the working branch. If you add modify something in a new branch and try to merge, sometimes it may cause extra troubles. So before that, we need to make sure all the change is approved by the programmer. In this example, we only change one file here, so that's very simple. But if for the real project, usually for the one branch, usually they have a lot of changes. They have some file be added, some new files, and some file may be removed, and some file has been changed. Here we only have one file has been changed, and this two are new lines, right? This original line. And one thing here is we can add some reviews, because suppose I'm another programmer of this project. I look here, okay, we found this file here. We ask, okay, why you need to add this line? So for example, you can ask questions and also provide suggestions. You say this is a good idea to have this, or anyway. So that is a way for people to discussion based on this piece, right? You can start review. Okay, so let's add something. You probably, if there are other part, you can add other conversation. You can add also add other conversation here. This part is good. Okay, add review, right? Put reviews, and then they are in the pending. If you finish your review, because you have add to review command, you finish your review. Eventually, they have something to review comes added. Something like you can ignore that because it's not so important. Okay, so that means you have put some review, right? So at this stage, this new branch is not merged with your main branch yet. We can have a look at first one. You see this our first one. Look at the MD file, right? See the MD file. This is by default. It display the MD readme.md. See, this only have one line, right? Clearly, in the main branch is still the initial one, and look at the branch, the new branch. In the new branch, they have this line, but most importantly, we look at the main branch. It's still the same, because we have pull request, but the pull request has not been merged yet, so they're still here. Then we look at our pull request. We have some conversation here. We have some conversation. So sometimes they need to make sure all the issues, because conversation usually means they identify some issues, right? So they probably say they want this issue be resolved, right? So they resolve the conversation, right? So here's one conversation. Here's another conversation. This conversation says this part is good. Okay, you can answer, no problem, or you can leave nothing, no problem. So this just, is conversation part. And also you can see this is resolved conversation. That probably means they have raise some issue has been resolved, you think that's no problem, and resolve the combination, right? And also there's still another one, why we need to add this line, please resolve this one. Okay, so all the combination has been resolved. That means no problem at all. Therefore, we can merge the pull request. Because for this project, we haven't set up the rules, so that means even without a comment or without anyone approve, we can still merge. But for some project company, they have strict rules for all the new branches. They must at least have two other programmer approve, and then they can merge. But in our case, we don't need that. We just resolve, and then we can merge pull request, right? So this command confirm merge. Okay, now merge is confirmed, and then we go back to this one. We look, this is the main, right? You can see in this main we have this line as well, so that in the main we have merged that. And then we come back to our part. We look at git branch. So we are in the new branch, right? We want to switch to main. Right? You can see main, right? Look how main this read means still only got this one line, so it means this is not in the latest version. So we can git pull, right, to retrieve the latest version. Now see we have this this file has been updated. Now we have this, so update to there. Okay. Check. Now we are in main. Now if we want to make another round of change, I probably create another branch and doing change and doing this. So that comes to the one circle of the code from create a branch, do some change, and send to the GitHub, and also create pull request and go back. So that's the whole round of stuff. So this is just practice the circle, and when you're going to do your real project, you need to do this many times. So that is the proper way for manage the project in the GitHub and the Git environment. Okay, now we look here, check out main pull orange, right? So that is okay. So that is the exercise of 3, right? Yeah, actually there are more command. It's better for you to do this exercise multiple times and eventually get familiar to them. And also on here we have a file called git menu. So this provide more command about how to set up Git, right? Git state, Git head. So what's the purpose of them? And also practice in the GitHub. So this definitely need some practice to understand this git branch remote, branch all, right? Check out. So look at check out and switch. They are more or less similar, right? Okay. The older version use checkout branch name. The newer version use git switch, local, right? Remove branch, remove remote branch and so on, git merge. So later on you're going to, through this course, we're going to have more git exercise. Gradually you're familiar, like restore, reset, clean. So they have quite a lot of command in the Git. Okay, and the last exercise for this week lab is to do the lab quizzes, right? The lab quizzes. I hope you can do this lab quizzes because we have question bank. Sorry, I'm a teacher, so I'm going to the wrong part. If I demonstrate how to do these quizzes, I need to use the student view, right? We are student. Okay, I come here to do these quizzes. So for this course, we have the final exam. So the final exam is just the question from the same question bank. So that means if you do the quizzes, you're going to see all the questions, some of the questions. But because we have a question bank, so one time you do the quiz, only some question from there randomly, and eventually when in the final exam, we're also going to pick up some questions from the question bank. So therefore, if you done this more than one time, you gradually you know all the questions. Repeat this exercise. You make sure you have memorized all the critical information for this course, right? So this I have tried many times. You can try this one. Every time could be different because I said we have a question bank. So every time you do the quiz, you just retrieve some question. Okay, sorry. I cannot use this browser to do that because this, oh, yes, I can do. That's good. Okay, level one quizzes. Right, so SDLC software development life cycle model where all phases are complete. It's called, all phases are complete sequentially with little overlaps called waterfall, right? Waterfall model. Okay, waterfall model is a very old model. Usually people criticize them with a lot of problem, but for the studying purpose, we need to know the waterfall model because waterfall model is the best model to explain the different phases. Even though in reality we use the something like agile methodology or other model, right? So, but what for is also we need to learn. In software design, refer to how close related and the focus of the single model class. Refer to how closely related. So that means cohesion. Cohesion refers how closely related and focus the responsibility of the single model class. Yes. Cohesion. Look here. String A equals hello, string B equals hello, right? The expression A equals B return, right? So this return true, right? Okay, even though there are two objects, right? But because they are string, because both refer to the same object in the string pooling. String pooling. Okay, look at here. X equals 10.8, Y equals X. The value of Y, because it's integer, right? So this just cut down this section is 10, right? It's not 11. Okay. Character A equals A, character B equals B. A return true, right? Okay, because between are cached because char because for character values between 0 and 127 are cached, right? So this is for the pooling section. The process of writing the source code based on design document happens in the source code implementation phase. Okay, the process of writing the source code based on the design document happens in implementation. Okay, that's multiple choice. Which statement about typecast is true? Implicit casting occurs when convert a double into. Yes, double to here, implicit. Yes, right. You cannot cast in from into no. Typecasting only apply to Boolean. No, is required when convert a double into. No, because explicit casting, yes, is required when convert double to, because this is going to narrow, right? So that's true. Then casting occurs when double. Yes, so this is not right because if you casting from integer to double, you can use implicit casting because it's from a more precise type to a narrow one. So this you need to use this. Okay. All right. So the question double A equals 10, double B equals two doubles. you return this return true or false. It return false because this is a wrapper object, right? But they don't have pooling. The pooling only happens for the integers, right? Because double doesn't use value pooling, right? Hopefully, oh, good, 100. Yes, I got this time 100% correct, right? But I still got sometimes I answer wrongly. Okay, try to do this exercise multiple times because every time you may receive slightly different questions that come from this one. So this exercise help you to review the critical knowledge about that week, right? Okay, so that's all for this week's lab exercise. Hopefully, this video help you to do your exercise. I hope you try to do this exercise by yourself, right? Even though after watching this video, it's still better to practice by yourself, right? Okay, thank you.